Hello, everyone, and welcome back to another Free Support Friday. We have a special guest with us this week. As you can see, my lovely daughter has been born. She's about a week old, but she wanted to come in, say hi to everybody, and I wanted to let you guys know that any beers for any questions this week you guys have, we're going to go ahead and donate to the diaper fund. As you can see, we are getting a little fussy, but I'm going to go ahead and switch back here for a second, and I'll be right back to kick this off the right way. Again, if you guys have any questions at any time, go ahead, feel free, throw them in chat. Let me know if you guys can see me all right. All right, we are back. So I'm going to go ahead and give this a few minutes, guys. Let me know, can you hear me all right? Can you see me all right? Everything good out there? We are in yet again another Free Support Friday. I have been sick all week, also chasing around a new baby, a little bit tired, but it is time to kick this off as always. And like we said, is this week, any beers bought for anything that you guys like or steaks are going to go to the baby fund for my lovely little daughter. But as you guys can see, I do have my energy drink, as it is tradition that we're going to go ahead and kick this off and get this thing cracked open. And then we're going to dive into some content. So give me a few moments here. Go ahead and check our support system, see if anything new tickets came in. I'm not seeing anything at the moment. So, yep, here we go. All right, so I'm going to go ahead and share my screen. As you guys can see, I've got a lovely part pulled up. Now, shout out to Matt Van Loo. You guys usually see him in our chat, but as you guys are going to notice, is he showed me this neat trick, which was something that was kind of flustering me for a while. Now, in the event that you guys are setting up to do a series of different jigs and fixtures, or a setup 1, setup 2, 3, 4, 5, 6, it doesn't really matter the number. But as you guys are noticing right here is I have 2 jigs, or 2 vices, 2 stocks, and 2 parts all defined as if I was going to go run this part on a machine. Again, 2 setups, 2 completely different work offsets. Now, this also works if you're not going to do this in an A-B kind of configuration. But what we're going to do is, what you want to do is make sure that you copy and paste an identical version of your part. You guys will see why here in a minute. So let's go ahead and jump over to the manufacturer side of things. I'm going to go ahead and create my first setup, and you guys are going to see me walk through this pretty normal. We get our Z-axis configured. I'm going to pick my model. Now, having components in your design tree to your advantage, this is where everything is going to be simplified and make life a dream. So as you guys can see, there's my actual part. Let's go ahead and grab my fixture. So I have my setup fixture for 1. Again, jumping over to my stock from solid, and that solid is going to be, if I can find it here, should be this solid body right here, which is actually residing inside my setup 1. So we're going to have to go back and make a quick change here. So that's my stock. And then my fixture isn't going to be the entire setup. It's only going to be the couple of pieces pertaining to that actual vise. So as you guys can see, this is a pretty normal workflow for a lot of you out there. We're going to go ahead and hit this with an adaptive clearing. Let's get a tool pulled in. And really all we need is just some type of roughing cycle to use to our advantage. So now, let's say you've gone ahead and switched over to doing your setup 2. This is where, again, we do our brand new setup. This is where we're going to define our model, but because we duplicated, right? So we did a copy and paste. I'm going to pick, as you can see, number 2 here. And just like that, that's what we're going to continue on to do our manufacturing with. Now, again, we're going to go to our fixture. I'm going to go ahead and pull all my information from my fixture. As you guys can see, my stock is from preceding. And just like that, going into my next setup, I need to fix my XYZ location. But you can notice how rest machining is coming through, and it's coming through to my second setup. So again, let's go ahead and make that change here real quick. Z-axis up, of course, X along the part. And just like that, whenever we're jumping between our two setups, using the activate button, Stuart, great to see you out there, buddy. We're getting not only a continuous machined process from one, but everything is passing through in real time. So again, the idea here, I'm going to go ahead and show all components, is our setup, when we're going from setup 1 into setup 2, that stock is automatically being recognized and passed through. So again, this is a really neat thing when you're trying to carry things through the system. Jeff, great to see you out there. Stella as well. Awesome not to see you. But as you guys can see, again, let me know if this is something you knew about or if you didn't. Again, I'm going to have some videos come out on this, but as you're seeing me do, I'm just copying down a couple of toolpaths. And what we're looking to do is use things like rest machining to our advantage if that tends to be the case. And I don't think I have rest machining. Nope, I do have rest machining turned on, so this is going to work out quite well. And we'll see our stock model populate from there. So again, I'm going to let you guys know if you guys have any questions, feel free to throw them in chat. I don't have a ton of stuff to put out there, but I do see right now that we can go ahead and kick off that stock model. Again, once that toolpath effectively machines out whatever we're holding on to, again, what you're noticing, anything that happens to setup 1, again, will automatically pass through to setup 2, even though it is two completely different models. So let me know, guys. Did you guys know this? Did you not know this? Do you like something like this? It's a kind of a neat way to go through the process, right? So, again, what I'm going to go ahead and do now is I'm going to go ahead and throw a few more toolpaths at this while we wait for those questions to start flowing in for today. So let's go ahead and do a little bit more machining. So again, there's my part. As you guys can see, we went ahead and roughed everything out. Now that tool's not going to be acceptable, but what we can do is we can go ahead and kick on our shaft and holder. We could actually auto detect tool length in this case. That is going to pull that end mill out to a length that we need. And we'll give that a few more minutes. Stella out there, Stella, want to see a quick rundown of the scallop toolpath? Sure thing. Stella, do you have a model that you would like to see that done on in particular? Because if you could, there's an email or there's a support email down below. You could send that in and I could show you in real time. In the meantime, I can always go out and pull up one of the actual sample parts. Now, I like to use the sample parts so that you guys have these on your side as well. But if I go down in that list, we're going to have what's called 3D milling, overview of toolpaths. Now, by default, this is actually going to have its own use of a scallop toolpath here. So again, we're going to go ahead and use F7. Now, the thing about a scallop toolpath is it tends to follow your outside profile inwards, and that is how you get the pattern to which you're machining. So with that, you can see there's a scallop toolpath here. Now, if I was to create a new scallop toolpath, so again, let's go 3D scallop. And let's say, for example, where is it here? Lost in the sauce. I'm going to go ahead and utilize that ball end mill. So again, let's go to a little bigger ball, 1/4 inch ball. I'm going to select a boundary and I'm going to use this profile down here. Now, what you're going to see is the same kind of thing happening all over again, where we are following the outermost profile working inward. So again, because of that rectangular shape, that's where we are getting towards the center. And it's going to look a little funky here because we are up milling and down milling. Again, this is something with a 3D toolpath that you do have to be aware of, because we wouldn't want to up mill or down mill. That would cause, cutting on the backside of our tool or plunging down. So there's other options to be able to machine something like this. But again, from a standpoint of scallop, scallop is a great toolpath. It calculates very quickly. I usually recommend to most, though, is using something like a additional set of parameters to control this. So for example, maybe we kick on slope. We only do things up to about 40 degrees. And as you're going to see, we're now going to get different areas. Again, we're no longer wasting our time with up milling and down milling. A little bit is all right, as you can see with that 40-degree transition. but we would need to utilize a different tool path to kind of machine the more steep areas. Stella, let me know, does that look like something good for you at the end of the day? Or did you send it a part for me to check out? So let me go ahead and jump back over to my other. I apologize to you guys out there hearing me sniffle and snuffle. I have what I'm pretty sure is a double ear infection. Both my ears are clogged. My nose is clogged. Let me know. Again, if you guys have any questions, feel free. Throw them in chat at any time. I'm going to go ahead and throw another tool path at this in the meantime. Is we could go back with a contour toolpath. Again, same kind of area that we're working within. And with that, we're going to actually use slope this time from 40 to 90. And what you're going to notice is we're going to get a different strategy doing our vertical walls on this part. Now, the reason why you may or may not want to do it this way is because I'm actually going to reorder these. And what that is going to allow me to do is to go through and simulate and see if we have any problems with collisions. So again, we're going to go to simulate. Now, some of you are going to ask the question why I'm going to simulate and not simulate with machine. Well, since the ability to do fast simulate with the GPU, we can actually move through this process much quicker at the end of the day. So again, as I'm going to go ahead and kick on stock, we did a very fast simulation, but what I'm looking for is when we start this tool path is if we did not finish the flat area first, we're going to have a risk of plunging that cutter across the part, right? Now, this isn't the best of examples because I opened a part with a bunch of tool paths on it. So what I'm actually going to do is I'm going to ditch everything in here, let the software do its job to recalculate. So again, as you guys can see, that's a little better use case. And because we never roughed out this part, why don't we do this proper? So again, we're going to go with a fixed size box. Let's round it up by 0. And then hit this guy with a roughing tool path, which I am going to go steal from my other tool path or my other part. So again, if you guys didn't know this, you can copy tool paths from one side over to the other. So again, I just pulled in my roughing, do a little reorderizing all this, and then we're going to regenerate that and see what we get. No part to send. Could you explain slope better in the scallop? Yeah, no problem, Stella. I would be happy to. So let's get this tool path on here so we can get a roughing cycle going. Now, some of you always do have that question, which I'm going to assume is going to lead down this part. Stuart, I'm way ahead of you. We're roughing this part out right now, but we're going to look at it a couple of different ways. So for you out there and those of you guys that didn't know, I didn't touch on this. I showed you how to turn it on. But notice my tool is sticking out a mile now. So if I actually go in and I click my warning, this is the luxury of that detect tool length inside the software. Because as you're going to see, is it has now pulled my tool out from 1.69 to 2.8. So I do need to make sure that happens. But as you're seeing in real time, I've actually automatically pulled that tool out for my simulation. And upon regenerating it a second time, that warning is going to go away. So Stella, real quick, what you see here is I'm actually using 3D roughing. And the reason for 3D roughing is because it is very model aware. It's detecting the model and setting all of my information automatically versus having to do 2D, which I have some parts I can pull up here in a moment and show you guys. So again, with 3D roughing, the big thing to keep in mind is that it is going to go to a maximum depth, as you guys can see here with this blue line. We get zoomed in there a little bit more. And then we are going to work up our part, right? So again, we want to go maximum and then back up our part. And if I was to turn off my links, you can see that a little bit better. This is what I like to refer to as jumping down the stairwell and then climbing back up. So if you think about a stairwell, and let's say there's a landing, right? So we jump down to the landing, climb back up the stairs, and then we jump down to the next landing and climb back up the stairs. And how that's all being calculated, again, if we go back to our toolpath in our passes tab, what you guys are going to notice is the first thing it asks us is max roughing step down. And then we have what's called a fine step down, which is more or less our step back up as we're working in that part. Now, for me, right now, this is set to 10%, and I might be getting a lot of additional toolpaths that I may or may not want. So it might be wise to up this number a little bit. And let's say we go 375 in this case. So we're going to make one big step down and then a half a step back up on our part. So Stella, you should have 3D roughing. There's no reason why you shouldn't. Under the 3D area, it's 3D adaptive clearing and 3D pocket clearing. I'd be curious to know why you may or may not have that. Now, what you guys are going to notice here is we do also have an additional setting, which is why we still have several other toolpaths happening here. So again, we could go back into our actual adaptive clearing, and that next area is called flat area detection. So if you're working on a part like this with a mold cavity or something, is in that case, the really only flat area is this floor and very minimal areas on this part. Now, if I turn off flat area detection, what you'll notice is in certain areas like these pockets, we're going to lose a lot more of those step downs. Again, there is a use and a time and a place for each scenario, but just like that, we are, again, jumping down one full step and then back up 3/8, causing a very large step down. But this leads me into a really good point, because if I transition now into our contour toolpath, and I was to simulate this toolpath, one thing that would be nice, Autodesk, if you guys watch my content, I know you guys watch my content, but you guys can notice right away, we're plunging into that material, right? So again, because of bad roughing, we are plunging in and tearing up a perfectly good tool where we need to add more step downs in there to get it a lot better. So again, this is just a good use case of why transitioning from a very heavy roughing cycle, we may need to go in and actually generate some of that minimum or those flat area detections. Again, we could bump that down now to that 10%. And then from there, we're going to see a reduction in step downs, and we should see a very good outcome when it starts to talk about that stair stepping on our part. Again, the more step downs you make, the longer it's going to take the machine, things like that. Stuart, does that answer your question about roughing? Because I could pivot real quick. Now, we could have roughed this part using what's called pocket clearing. And with the pocket clearing strategy is what we're going to see is this is aimed at doing a maximum step down, or not a maximum step down, a consistent step down. And then we are going to only step downwards, right? So again, as our maximum roughing step down is 50 thou. Now, I do need to turn off rest machining because we're doing this twice. But if you wanted a natural tool path, you're going to notice it seems like there's a lot of tool path there. Again, we are making just a consistent 50 thou step down. And with that, we're never stepping back up. So now there's a use case for this, is you would never want to do something like this with necessarily a traditional end mill. But if we were working with pocket clearing and doing something along the lines of, let's go for a bigger tool here. Let's say your company spent some money on a big 1-inch tool and it's a insert or a high feed mill, right? So again, we could take a much larger step over by default. So, and then we could take a little bit more of a step down. But what this is going to allow your tool to do is remove material in a much faster kind of scenario. So again, we've reduced our cycle time by a ton. It's like 20% of what it was. But you're seeing that that stair step or the way that actual surface is being generated, again, for demonstration purposes, what we're going to do is we're going to duplicate my setup. And then I'm going to bring pocket clearing to the top and remove adaptive, just so that we can have a side-by-side comparison. So again, looking at our step downs here, again, we're stepping down consistently each and every time. Now, if we're doing adaptive clearing, we're going to make a major step down and a minor step down back up, or a step up, I should say. One of your machines does not have high speed. So if your machine does not have what's considered high speed, what you need to do is pay more attention to your point cloud data than anything. Now, I'm going to show this to you guys because you're going to notice this file is 1 megabyte. Where my adaptive clearing is 1.4 megabytes. Now, the big difference between these two is if you look here in the middle, we're making a bunch of arcs because we are swooping through here. One thing that I like to do is I like to go in and on my toolpath visibility is I'm going to turn on what's called points. Now, every time you see a black dot, it's an additional point of data. It means your machine has to change direction. I always pick on the Fadal guys for this, but if you're on an older machine, you're either going to data starve or your servos are not going to keep up. So as you're seeing, in Stuart's case, it could be a lot of small segments, or it could be hundreds of G3, G2 motions. It really depends when we spit out that code. But that is all something that's going to come from your tolerancing and your smoothing. And we're going to see that here in a minute. But I want to show you guys, we're turning on the show points because you're seeing all these little black points. The lines look a lot darker. But if I was to switch gears now and look at pocket clearing, we're still going to get quite a few dots. Again, it's just a circular toolpath. But if you look on the outside here, we're doing a lot more straight line and linear type work, right? So again, if we go back to adaptive clearing, we start to clear out in between these two. We're making a lot of arcs. We go back to pocket clearing. You're going to notice that it's staying much more straight line and linear. That's where we're seeing a reduction in data, right? Now, from that, Stuart's asking about further reduction. So what I can do is I can go in, and remember that 1.4 over here on the left, guys, is I go to my passes tab. The very first thing you do is you have tolerance. What this is, nothing more than how close we are going to be to the model, right? How accurate do you want to follow your model? Well, we're roughing. We can be a lot more lenient with that tolerance. Now, the greater the tolerance is, the less likely you're going to get arcs, and you're going to start to get straight lines, which are going to be more stop signy or hexagonal looking. Now, if I scroll down to the bottom, though, on the other hand, you have what's called smoothing. Now, smoothing is something that will actually increase arcs by reducing points along that way. It is an additional adjustment. So again, we could turn on smoothing in this case, and I'm going to up this a little bit to about 1 thou. And what we're going to see is a reduction, hopefully, in that file size once it spits out. And just like that, if you notice, my actual points have been completely reduced across this entire part. I've actually cut my program down to 1/3 of what it is. But this works with both toolpaths. So again, we go down to our pocket clearing, jump over to my passes tab. I can go to smoothing. Again, we're going to go to about 1 thou. I like to use about 25% of what my tolerance is. And this works really, really good on 3D toolpaths. Now, again, as you guys are going to see, all of a sudden, my pocket clearing has actually not reduced the same amount. Again, there's just a number of points that need to be reduced. But I would also have you guys keep in mind that if I was to compare and edit these two, so what I did there is I highlighted both, did a compare and edit, and I can search something like step down. So keep in mind, on adaptive clearing, I have a fine step down of 0.075, where again, we're doing a 0.75 step down and then a 3/8 fine step down, where on the other side of the table, I'm doing a 100th thou step down consistently. So in 3D toolpaths, it does give you bigger programs. Not so much. We'll go ahead and take a look at it here in a second, Stuart. I'll show you a couple of tricks again. But again, just keep that in mind. The reason why we have a little bit more lenience on the adaptive clearing with our step down versus a constant 100th thou step down, that's why we're seeing that data point reduction not necessarily happening as much with the same smoothing settings. Now, changing gears here, let's talk a little bit more about scallop, right? So here's my scallop toolpath. We don't have smoothing turned on, but I can again go back to my passes tab, kick on smoothing. Once again, we're at 4/10 and 4/10. I'm going to leave that as a default. And let's go ahead and see. So we're at 1.5 megabytes. And just by turning on smoothing, we've actually seen no reduction. And again, the reason for that can be because we're so close to our accuracy of our model that there's not much of a change that we're going to see. Now, this is in my personal opinion. If I was 3D surfacing something on an older machine, the accuracy of the machine makes all the difference. But I might start to drive up my tolerance of how close my toolpath is and allow my smoothing to hopefully help a little bit more from there. So again, by doubling or 2.5 timesing my smoothing, I've reduced my points a ton here, and I've cut that file down by quite a bit. Now, again, the surface will suffer a little bit depending on how crazy you're trying to get. But if I really had to put my 2 cents in, this is where we're starting to get into that realm of talking about why the machining extension is better. Steep and shallow would be the way to go, because in steep and shallow, you now have things like the ability to do smoothing based on fitting arcs, or even using even step down. So again, if I get my fat head out of the way, give me a sec here to populate this up. But as you can see, is we can smooth based on arcing and evenly spacing points versus just giving it a number that's going to be randomized. So again, if I was to do the same toolpath here, you guys are going to see me cheat. I'm going to right click derive into my 3D steep and shallow toolpath. Again, we're going to see that our tolerance is 1 thou. We're going to do smoothing based on fit arcs. And let's see what that gives us to start with and compare the two. Now, for those of you that don't know, steep and shallow is kind of a combination of a scallop toolpath with a contour toolpath, which is why I'm getting two different strategies in the middle of my part, but I can remedy that. So again, we could go to our passes tab. I could say shallow only. And just like that, we're going to see what's going to look like an identical scallop toolpath with a lot more adjustments and things that we could do. So again, even smaller file, same tolerance, but now we're fitting arcs, which if you guys notice these points, they look a lot cleaner if you're looking for a very clean pass up and over. So we got feed optimized on the bends, but it's not doing anything. Machine takes off and I run fast feed and it's okay, fast for most of the toolpath, but going around corners, wow. So what feed optimization is really built for is, let me pull open another part, is let's go ahead and get my other part that I like. So I know we had Stella out there asking about 2D roughing and things like that. This is a much better part. It's the 2D over 2 toolpath. But in this part file, let me remove everything out of here. Get a look at our stock here. Is if I was doing 2D roughing, for example, I'm just going to show this to you guys pretty quick. Again, we're going to go in. Oh, there's 3/8 tool. 2D toolpath, I'm manually having to select everything and create that different type of strategies, right? Now, where the value comes in of feed optimization, what you guys are seeing me do here is I'm going to go ahead and make it so that this part is normal. But if I was doing a 2D contour, for example, with a small end mill, and we're going to turn on feed optimization, what you're going to see is based on the corner, when it goes into a corner that is too close to size to the end mill, we are going to get a reduction in feed rate. Now, I did this with a 1/4 inch end mill. However, the radiuses in this corner are bigger than 125. So let's swap that back out. I don't think they have a 1/2 inch in here. We might have to go get one. So let's go up to the 3/8 to see what we get. If not, we're going to change our chain. Nope, there we are. So we are getting this now. So again, if you guys can see it, let me know if you can't see it. I can actually turn the model off. Is when I go into this corner, that yellow is considered a feed optimization, right? So feed optimizing means we are going to slow down our feed rate because when we go into this corner, we're going from shouldering to slotting. So again, we need to reduce so that we don't get those nasty burrs and blemishes on the inside corners of our parts. Now, feed optimizing, if we go back to 3D machining, so let's go ahead and go to our passes tab. Again, if I turn on feed optimization, it works the same way. However, again, this is a 3-dimensional kind of configuration. So what I'm going to do for you guys is we're going to get steep turned back on. We're going to ditch slope. But what I want you to see is when we calculate this toolpath, depending on the size of our tool, again, guys, let me know if you can see this here, is these yellow little segments, right? I'm using a 1/2 inch, a 1/4 inch ball. That radius that I'm going into is within that parameters. And as you're seeing, as we go in, we slow down our feed rate, and then we come back out at an accelerated rate. So Stuart, the whole idea of using feed optimization is more for when you're hitting internal corners. Now, you can do it for external corners if you want it to slow down. Usually not needed. Give me 1 sec here, guys. Got a little stuffy nose. All right, we're back. So, Doug, I see you out there. Doug, great to have you today. So, is there a way to orientate to a face or a surface to be horizontal to just the view or not rotating the model? So, if I wanted to square up to something inside of Fusion, I can precursor select that surface. And then down on my toolbar, I do have what's called look at. So it's right here at the bottom left. If I click look at, it's now squared me up to the surface. Now I do have the ability to also use my view cube as well. As you guys can see, I can orientate based on that view cube. If I actually left click on the view cube and drag, it will allow you to pivot as well based around your 3-dimensional rotation. So Doug, let me know, is that what you're looking for at the end of the day? Again, it works anywhere there's flat. So if I pick that flat surface there, I hit look at, we've now squared up to that flat surface. I believe if we were more horizontal, I might be wrong. Nope, it's still always flipping me down based on keeping that surface in my XY direction. Cool. Any other questions outside of that, guys? I'm going to go ahead and open up my ticket system to make sure nobody's put in any tickets. Go ahead and see what's going on. So let's see here. Make sure we don't have any tickets. Stuffy nose again. It's been a rough week. I do see Not Elvis sent me a ticket. Not Elvis, are you out there? Go ahead and let me know in chat. So, Stuart, great question. You're getting a lot of as-built motorsport parts. They're all over the place, but how do I orientate them to move them? So, this is actually a really good video, and if I remember correctly, Brad Tallis out there. Awesome, Stella. I will take a look at your part here in a minute. Brad Tallis does a really good video on this, but basically through the design side of things, maybe I could do it with Stella's part. Stella, give me a sec here. Let me get this part pulled up. Again, guys, if you guys have questions at any time, feel free, throw them in chat. Hanging out here today, basically until y'all are out of questions. So let me get this downloaded. Again, it's going to take me a couple of minutes. Did you guys catch it in the beginning when my lovely new daughter? All beers this week for anybody that has a question that wants to give a little bit more. You could buy us a beer down below in the link in the bio, but they're all going to the diaper fund around our house. Let's go ahead and get this uploaded. An ashtray, a 3D scan ashtray. This is going to be interesting. But what I'm going to do, Stuart, for you is, can't spend the model. I'm in the pub. Stuart's already way ahead of us for Friday. We are now live at the pub. Stuart, where are you at? You're in the UK, aren't you? So let's go ahead and pop this model open here real quick. And let's see if it's near the origin. It actually is, which is kind of a pain in the butt. So what I would recommend is, one, I'll try to find that video, Stuart, if you want to send me an email, but basically in a short way around it, you go into mesh and you do direct edit. You're going to have to define what you want to do, but there's also the ability to do a mesh align. So if you are dealing with a mesh, this works quite well. So if I wanted to do mesh align here, this is where I can now define what I want to align and how I want to align it to get it back to my work coordinates or back to my origin. Now, if you're not dealing with that, if I jump back to this other lovely part, is what I usually recommend to most people, again, my origin is kind of stuck here in the middle, is you can do a move command to get it to where you wanted, but I would prefer is to use a joint, in my opinion. So for example here, let's just say on this lovely flat surface, I want the center of this lug up here to be my alignment, right? So again, as I'm putting my mouse on that surface, I can hold control, and then if I go to my edge or that center plus, that is what I'm going to snap, and that's going to be from there. Let's get my models out of the way. And then I want to go to the joint. What you're going to see here, if I turn my part back on, is it is now rotated down and around to the origin. And with that, I can flip it up. And again, this is more of the Mastercam SolidWorks side of me, right? Let me get zoomed out here. Is I am now orientating blue, green, and red based on the world coordinate system. So as you guys can see, is using joint, I can align based on the world coordinates XYZ. What this is now utilizing is the joint. The origin of my part has now been moved. The bad news is is none of my table jigs and fixtures came with me. Now, this is one of those use cases that it is very wise when you guys are building this stuff out. I'm going to undo this here real quick. Is that one, you make sure you have your timeline on. So we're going to go ahead and change to parametric modeling. And then what I would like to do is I am going to rigid group everything in this case. We're going to grab our table, our part. They're now all rigid grouped together. Confirming that by turning on my origin. If I click and drag, everything moves together, right? So now I could just rinse and repeat what I just did. So I'll just do a joint from this lug. I want to put it on the origin, flip it the other way. And now you're noticing everything snaps down nice and perfectly aligned to that origin, right? Again, my view cube lines up. If I jump over to the manufacturer side of things, now I do have settings on my side that where when I activate my setup, it automatically orientates my XYZ and sets my view cube. And you guys can do that down here using the synchronize active setup. Again, checking all three of those boxes makes it so if you are jumping between setups, good example of this, setup 1, setup 2, it's automatically turning on and turning off everything as well. So Stuart, couple other questions there. So Stuart, you actually don't need to delete the entire assembly, and I'll show that to you. So let me jump back over here real quick. If I go back to design, and let's say, for example, I only want to output the part. I don't want to output the rest of this assembly. What I would highly recommend you actually do is called derive. And what a derive will allow you to do, now mine will not allow me to derive right now because I am completely butchering a perfectly good demo part. So let's get that saved. Now, when I do my derive, what is going to happen is I'm going to push that out into a brand new design, and I'm not going to carry anything with it, right? So any updates that now happen to the original part would actually pass through to my derived part. And if you guys wanted to see that, say, for example, good old engineers say, you know what? We no longer want any of these features. Just like that, I removed them. I hit the save button, and all of that is now going to push out. And we're going to get this lovely warning that we all love, which means the model has updated. And just like that, it has removed all those features. So Stuart, I would highly recommend that you use the derive feature versus trying to remove their assembly from the assembly file. Just push it out to its own. Not good old fashioned, not Elvis, aka, it's going to be hard for me to put those two together. Stella out there saying that he did a align. So again, from the solid side of things, you could do an align. In this case, you can't align a body, especially if it's a mesh. So my questions to you now, Stella, what are your questions about the mesh in itself? So Stuart, even though it is wonky out in space, that is another option. You do have now the ability to do what's called a constrained component. And what that allows you to do is a 3-face alignment. So let me go ahead and back this up for you guys. Let's get back to that 2D toolpath. You guys wondering, I'm removing the last two things we did. So now we're still in a rigid group. But let's say, for example, this time around, I wanted to go ahead and do what's called constrained component. Now this allows me to do things like a 3-face alignment. So as you guys will be able to see is I can pick face A and where I want to align that to. Face B, for example, might be this back wall and this surface again. So again, now you're seeing me slide over on top of my actual origin. Lastly, I would want to make a third constraint of the highest point of my model. Let's say it's right here, and my Z height. And just like that, the system has now allowed me to create my origin or move my part based on 3 surfaces wherever I need it to be. Again, this is a neat trick to use that ability using what's called constraints. Now, constraints are familiar from sketching, but we're constraining components. Again, components is the key element here for you guys. So that would be the #1 thing to get you set up and going. Stella with a adaptive roughing and a scallop on the tray. I think I earned a beer. Stuart, I appreciate all the beers. But like I said, these are all going towards the diapers. So let's go back to the ashtray. So a couple of things I would recommend right off the start with this is actually a really clean STL file. Now I say that because there's a lot of different STLs. If you 3D scan something, you're going to get a much more dirty file. And by dirty, I mean, is these are all surfaces that have been modeled in a actual STL modeling software, or this was a solid that has been converted into an actual STL model from a solid model. So what I think I personally would do on something like this is I would still jump to the mesh workspace and I would actually look at converting this. Now, again, what we need to do is we need to actually repair it, make sure that it's watertight. Quick analysis says this is a watertight mesh. There is no problems with it, so we don't actually need to repair anything. We're still going to do it. Now, I'm going to turn around and generate face groups. And what you're going to see is the idea of face groups by default is it is going to look at a lot of those little triangles. Should have. Let's go back and take a look here. Is one more time, let's go ahead and face group count. So we're going to actually need to increase or decrease our angle. Let's go. There we go. We're getting much better. Give her a second here because I removed all numbers. It went down to 0. As you can see, what is now happening is anywhere there is currently color on this part, it is thinking that is all one face group. Now, if you think in the world of modeling, we would still need to split up this even more. And I'm doing this in a very fast process. So let's go ahead and reduce that even more. Again, what you guys are seeing is that was probably too far of a reduction because this should be one clean surfaces versus multiple surfaces, right? So again, let's go ahead and up the ante just a little bit here. We're going to go back to 1 and see what we get. Now, I'm going to leave this alone for right now. We could obviously do more with this, but the whole goal would be to convert the STL back to a solid model. And that's what you guys are kind of seeing me do. So again, this is where I could go through the process, convert mesh back into a solid. Again, we're going to get warnings along the ways because the amount of stuff, as you're seeing, is we can go based on faceted, prismatic, or organic, parametric, so forth and so on. Again, a lot of really good videos out there from a lot of the people that we partner with here at jitcadcam. Now, I'm going to give this a go to see how bad it really could be. I don't think it's going to be that bad, but I'm always shocked to see. Stuart with the beer. Now, keep in mind, guys, as you're noticing, I've converted this back to a solid. It is a watertight solid, and this is where I was talking about the number of facets being a bit of a problem. So again, the idea would be is repair the mesh as much as you can. Now, that's not to say that you can't actually machine against this, but what you're going to notice is if I go back to manufacture, I create a setup, we're going to get a lot of toolpath points because of the surfaces. So give this a few moments here. We're going to go ahead and create our setup. It's thinking about grabbing our part. Jacob out there saying that he puts it on a accurate model or accurate mode usually instead of fast. Again, that is a great way to point it out. I am not a mesh expert by any means. That's the last thing I think I am at the end of the day. But the goal would still be the same. As you guys can see, I now have my actual part that I'm machining. I can come in here, do something like 3D adaptive clearing, possibly instead do pocket clearing. Really just depends on the tooling at hand. I think this is smaller. I don't think we're making no 6 foot by 6 foot ashtray. So let's do our adaptive clearing, pull our tooling. So again, I'm going to pull a 1/2-inch end mill right out of the default library. And we're going to go with some aluminum roughing. And we're just going to let this thing do what it's supposed to do. This is what Fusion sees even with solids. No, Stuart. So what this is an operator on me issue is I converted a mesh, but I failed to do it properly, as Jacob has pointed out, is these all should actually just be one surface. This all over here on this right side should be one surface. This is just nothing more than a simple fillet. 200 by 200 or 100 approximately. Yep, so 200 would be, what, 8 inches technically? Actually, it is quite big. As you guys can see, my tooling is tiny in comparison. Stella, is that 200 millimeters, 200 centimeters? So we might have a scale issue here as well, which we can fix that as well. Also would explain why my setup is taking forever. So let's do this. We're going to go ahead and clear that toolpath out. Again, let's jump back to design. What I'm going to do is I'm going to unconvert this. 200 millimeters. Okay. So let's go ahead and run back our timeline. There's going to be some pauses along the way, guys. If you can think we're rewinding the VHS tape right now. Go ahead and check. Got some interesting things coming into my email list. Let me go ahead and pop over to my ticket system. Another try. I'm assuming somebody's out there that just sent me. They have yet to talk in chat. You are 100% correct, Jacob. Again, I failed to do this the proper way, so we're going to go ahead and reset this as soon as it stops locking up. And you could delete the triangles. It's, no offense, Stella, it's not a bad way to do it, but it would actually take quite a bit of time to try to re-engineer those actual areas. So give this a second. We know Fusion. When you get this screen, you go ahead and pause. Occasionally, you go ahead and jump over to any new content ideas you guys are thinking about. I'm thinking about kicking off Stump the Chump. What do you guys feel about Stump the Chump on Monday? You guys send us a part file. We'll go ahead and program it up live, and then we'll compare it to your version of the file, and we'll see what everyone thinks is a better version of that. So you guys let me know. You guys think we should start a Stump the Chump? See if you guys can make better CAM programs than yours truly. Now, I will need some information on this, of course. Obviously going to need to know what kind of machines you guys are running on and things like that. But again, we have a lot of different things that we've got in the pipeline that we're thinking about doing. Let us know. Do you win a beer? I don't know if I can afford that. I got a new kid. I don't know if I can afford paying out beers. I tell you what, you could be bragging rights that you beat Fusion Phil. So I'm going to go ahead and jump back over here. I think we're going to have it where the good old-fashioned Fusion is not going to be happy here in a moment. It is fully locked up. Again, operator error, guys. As you guys see, Jacob is pointing it out hard. Jacob, I'm going to have you come on live and do this for me. How about that? Thank you, Stuart. Manic Mondays. I like that. Manic Mondays. That's a good one. I was thinking modeling Mondays. Who knows? So again, I'm waiting on my Fusion to boot back up, guys. Give her a second here. She is fully not happy. You'll email me a tutorial. There you go. Jacob, if you have a link to tutorial, throw it in chat right now if you can. If you can't, send me the link and then I'll populate it into chat. Again, full disclosure, guys, I am not a mesh expert by any means. Just want to make sure everybody knows that. Meshes are like a black witchcraft that I don't get. That's all there is. All right, we got Fusion coming back up. We're not going to open that old file up. Let me get my screen back up here for you guys. You're going to screen record. Jacob's going to screen record a mesh video. Jacob, I look forward to seeing it, man. I will gladly post it on this channel for you guys. But let's go ahead and jump back into it. So I was told insert mesh. So let's go ahead and go mesh. And we are going to insert mesh. Let's see which way it's going to want it. If it's going to want it. I might have made it angry twice in a row. Here we go. Free Support Friday. There is no mesh. It's going to want it from my desktop. There we go. Hey, look at that. So, as you guys can see, much better. Unit type, I think, what are we going for here? Millimeters? Center, move to ground. This is all lovely stuff. Again, we're actually going to go to inch. Big fan of inch. And from there, it's not a matter of remodeling it, Stella. As you're going to see, is I would have had to pick all those actual triangles, which can be a little bit of a pain in the butt. So, Jacob, am I good so far? You tell me, man. to go ahead and measure this real quick because presumably we are off at our scale. Again, on me, guys. It's not on the software. It's on yours truly. So again, we'll go ahead, insert mesh, grab it from my computer again. There should be a, do I have to leave it as millimeters since it is millimeters, or scale it? Jacob, do you have our cell phone number? You could call me on my cell phone. Walk me through this. I think everybody's getting a kick of the yours truly out here failing. Try it this time. Hey, distance 4 inches. I think we got it right that time. So now that we have that mesh in here. Yep. So I think we're good now. Roughly 4-inch distance. That would be what I would assume an ashtray would be. But now you're saying is based on that, you want to generate face groups based on accurate. This is where it yells at me. It technically isn't it millimeters by default is what an STL is saved in. All CAD and CAM software is actually metric in the background. Isn't that the ruling? So give this a second here. We went ahead and went with accurate. We're going to see how long this takes. We're going to put it to the test live. If you guys do have questions, again, Pumpkinhead TV. So there we go. We got accurate. We actually got a pretty good result. We will have to do a little bit of combining of some of these because I assume this should have been a clean fillet around the corner. Plastic and an ashtray does not mix well. No, it does not. But the good news is the request was for machining. So either this is probably going to be billet aluminum or possibly a CNC router. So again, as you guys are seeing, I've generated my face groups. I should go back to the basics, guys. This is what we teach. Always start left to right. As you guys are seeing, I'm skipping steps here. But if we wanted to combine things together, again, the goal would be is to clean up these face groups as if the model should reflect what it's going to end up with. Hey, there you go. Learning something new. Jacob, where do you work? Where are you from? Are you from one of my competitors? If so, don't put it in chat. Wood and ash don't mix well. Hey, Pumpkinhead with a 3D printer. What 3D printer did you grab at the end of the day? So again, we've repaired. I've showed you guys now. We've combined a couple face groups. Good example down below is, again, based on those corners, all those individual areas, merging them down into one. As you guys will see here, if I convert this, I'm going to assume real quick that it's going to put everything back together. So again, maybe we want to combine this all into one surface. And if you guys want to see that one more time, over here on the corner, I'm going to grab everything around this way. And what we're doing is trying to get these face groups so that that is going to be one individual surface when we convert it. Matt Boyance, hey, what's going on, buddy? So from here, let's go ahead and try this all over again, but we're going to go ahead and do our convert mesh. Now, this is again, guys, I'm no expert here. We don't need faceted. What I think we want is actually prismatic. Is it not? Jacob, tell me in chat. Subtract manufacturing. Awesome. How do I know? I know subtract manufacturing in some way, shape, or form. I can't remember what it is off the top of my head. Yes, prismatic. See, again, guys, I don't do meshes all day, every day, but just like that, this is the fun of this. This is why we do these free support Fridays. As you guys can see, Jacob is an expert teaching myself, but had I face grouped my other two corners here, they would have been much cleaner. But this is a good example of why you would actually face group those guys together so that, again, your end goal is to basically make that one clean actual area. So, we talk about it on taps and patience. You can delete the faces on the fillet and they will self-repair. Yep, pretty common. Another good way to do that if you guys are looking for some repair techniques here is if we go into modify, simplify, and then what we could do is we could do what's called remove features. So we don't want to select everything, but we can go through and pick individual faces and stuff if you're looking to remove holes, things of that nature as well. So it's just something a little different. Again, modify, simplify. You can remove faces. As you guys are seeing here, again, you could select those faces and things of that nature. As pointed out, if I do the good old-fashioned control, now what we're seeing is, in this case, there's actually a hole there from inside to outside. So there might be more to this model than what we're being led on to believe, because even though we did convert it, it looks like, maybe I just backed up too far. Let me go back forward in time. There was an issue when converting the mesh, which would lead me to believe that there is actually a hole there, and we should have did better face groups. So let's delete it. Let's go back in time, generate a couple more face groups real quick for you guys. Get zoomed in here. Not looking at my chat. Jacob's out here hijacking my show. No, it's all fun. So again, we'll go ahead and spin around. Get this last side one more time. I didn't realize on this part there's also an inside area as well. So again, we would have to face group this inner area as well. As you guys are seeing, it's just a good example of what to expect and what you're seeing. So actually, I don't think, Dylan, this was a scan. This is almost too clean to be a scan. And I say that because those triangles and all those little facets in here, they all run in the same direction and they're all consistent and mirrored. There's no way a 3D scan would give us that clean of data, if that makes sense. So again, you're saying if we did a, Jake's out there, rule of thumb, if it was created in CAD software, it should be reverse engineerable. No problem. If it was a scan with noisy data, yep, just like I said, is what you guys are seeing here versus, not to throw somebody under the bus, but if I go back to another file from last Friday, you guys saw this actual part here. This is like a dirty 3D scan from a piece of software, right? So again, yeah, EJ, as you're seeing, is this scan file that was sent in yesterday or last Friday. Very, very dirty. There's a lot of rectangles. They're not really aligned to anything. It is a mesh in space. However, this here looks like it was designed in a CAD software and probably started out as a solid model and converted over a few times. So again, I'm being told that repair would be a really smart way to go. Let's just go ahead and jump back in our timeline, completely ruining the system one more time. Do our repair, stitch and remove. It looks like everything is good. We could generate our face groups again based on accurate. Give this a few moments. EJ emailed in. EJ's also getting called out. I do not have permissions to access that link you sent me, EJ. I don't think you turned on the ability to view or something. And give me a couple of seconds, guys. Just cleaning out a couple of emails from all of this. This is still calculating. Any other questions in the meantime? I see you guys really going off in chat. Jacob's calling you out hard. So there we go. There's our actual face group translation. Again, I think my accuracy was too high, Jacob. Let me know. Yep, the boundary tolerance. That's what I was kind of thinking too, is if I'd go back to that, up this a little bit, we should be able to see a little cleaner as well. Correct. So Stella is mentioning that there's also the ability to look at inside versus outside and things of that nature. Any other questions? Any other part files you guys want to see? I'm going to continue with this until I see something else come up. But at this point, we're really hung up on the whole idea of converting a mesh back to a solid more than anything. Jacob has so kindly volunteered to create a video that we could post on our channel if you guys want to see this. And what I was hoping was a simple STL file has turned into a complete nightmare on my end. So again, definitely much better by upping that. So again, this looks way better. Looks like that actually was the trick. Again, we go back. We now do our convert mesh back, parametric, prismatic, and just like that, we have a super clean model reversed engineered from A to B. It is watertight, and I know that took a lot of time. This is why you guys get to charge a bunch of money to your customers. And we did get a couple of weird surfaces. Again, not chalking this up to anything bad. That's 100% on me. If I scrolled back one, again, we could go ahead and combine these three guys together. Now that I've got the workflow down, I'm dangerous. You guys notice this? So again, just like that, I just added those into my face group. I got everything squared away. This actually looks way better, and I'm actually happy. Took a lot of fumbling to get to this point, but let's go manufacture it now, right? So we jump back over to manufacture, do our setup. Just like that, we can now jump in with our adaptive clearing. I'm going to go ahead and grab our 1/2-inch end mill that you guys know. 1/2-inch fill over here. Some of you are thinking the wrong thing. Don't put it in chat. So as you guys can see, there's our 3D adaptive clearing on the outside of this part in particular. Now, again, there's going to be some arguing out there. I would tell you, if you're going to be doing something with 3D surfacing quite a bit, I would go down the rabbit hole of the machining extension, because we could steep and shallow and then chase that down with what's going to be a contour. So let's say we swap out now to a ball, 1/4-inch ball end mill. Again, utilizing our steep and shallow, you're going to now see we can surface both inside and outside all nicely. Again, a couple of little areas where, oh, excuse me, guys, blending. But if I needed to go to a smaller end mill now, this is where I think the value is if I swapped out, let's go ahead and, we're not going to be able to measure this guy the best, but if we go edge to edge, we got a distance of 0.41. Actually 0.22. So we need to go much smaller. Again, I could go now to the corner tool path, go to a smaller ball end mill. We're gonna have to go way down there. I don't think I have anything in default library. To be 0.33. But again, this is where I love the ability to use the machining extension, because my corner strategy has rest machining based on a tool. So what you guys are now seeing me do is go back and say, I used a 1/4-inch ball, go find all the areas to machine based on that 1/4-inch ball. Stella, we live dangerous, bro. No saves needed. We're just going to crash it. Let it happen. Not true at all. Stuart, remind you how to save my defaults. So if you wanted to save your defaults or make a backup of your defaults, again, as you guys can see, is you can actually go to the manage dropdown and you can export your default settings at any time. Now, I would need to know a little bit more information outside of that. So, did EJ send over an updated file? Let me go back here. EJ, did you send another link? Because this one is not working. Also, I would be happy to quote doing anything to that part file, but I think Jacob's price is going to be better than mine, because my price is always 2 blank checks. You forwarded it. Forwarded to where? Because I don't see it anywhere, and the one that I do have doesn't allow anything. I just have that one that you said another try question mark. Is that the same file, or is it something different? So again, as you guys are seeing, the value of the machining extension on something like this, we're auto-defining and picking up our inside areas. Now we are doing some stuff on the outside. So again, I could change that up with nothing more than creating a nice little selected boundary. Again, I could define that boundary a lot of different ways. I'm going to go ahead and use the top edge of my part. And just like that, we've now limited our toolpath to stay inside basically that female area of the part. See you, Jacob. Thanks for all your help, man. I'm glad you were here today. You made my life 10 times easier. But as you guys are seeing, again, there's our toolpath. If you wanted to do something like this a little bit more traditional, you would probably start with something like a contour toolpath. Again, going back to that 1/4-inch ball end mill, we're now 3D surfacing around basically all of our steeper areas of our part. Now, I did see a very interesting ticket somebody, or an interesting post on Facebook somebody had, is where that toolpath didn't quite go all the way down the part, or it went too far. This is where something like your contact point boundary is going to be your best friend. So again, we're center on that boundary. which is a silhouette, and we want to extend our boundary based on the radius of engagement of our tool. So again, as you guys are going to see now, we're going to machine all the way down the outside edge of our part and giving us those nice clean toolpath lines both inside and outside. Now, what I would highly recommend is going in and now utilizing something like a flat strategy. And what the flat strategy is going to be good for is cleaning up anywhere that's flat on our part. So again, as you guys are going to see here, we're going to knock down all the top areas, anywhere that end mill can reach. Now that end mill can't reach in our floor area, so I might have to use a smaller end mill, but that's basically your work through. So again, we've hit our flat areas. We can now do our 3D scallop as somebody was pointing out, or you could do what's called blend if you had the patience and the time. So let's go ahead and go with scallop. In my opinion, I think it's going to work out much better. Back to our 1/4 inch ball end mill. Now I would use slope here because we don't need to do anything at 0 degrees. We need to be just over 0 degrees so that we don't machine our flat areas. So again, what you're seeing here is we are going to 90. We really don't need to go to 90. But as we were looking at originally, this is how we can control a lot of our tool paths based on utilizing things like slope. If I reduce slope to 70, so forth and so on. And now you're seeing is that's obviously a smaller angle than 70. Again, I could go back, change that out, whatever I need to do to get that tool path much easier where I want it at the end of the day. Questions outside of that? So again, as you guys are seeing, is I'm now utilizing slope to control that scallop tool path to basically work on the filleted areas in this part. And then again, we have a flat strategy. We have our contour for our steeper areas, anything and everything. So Stuart, I normally extend the offset surface. Do I need to, or can I use an offset? Stuart, I'm going to need a little bit more information on that. Are you saying you changed the model to extend a surface? And EJ, that part that I opened up, that was the part that you sent me, right? This guy right here. To go past the edge. So in the event, it depends on your tool path that you're doing. As you guys are seeing here, what I would actually need to do for this particular part is we would need to be able to go past model bottom. And I'm going to go ahead and punch that in here real quick. But as you're going to see, is now because I'm going past model bottom, tangential extension, or not tangential extension, contact point boundary is continuing down that actual shape. Now, it does get to a point down here at the bottom where it starts to go vertical. But that would be one of my questions is, do you need to continue that surface outside of that boundary? Or are you happy with just getting to that edge itself? Because if you start to extend your boundary, it's not going to extend your surface at all. So EJ, you did send me a step file and I've gone through all of these. And the problem is that step file that I received, I think was this guy here, which still had kind of the same functionality problem. This is a mesh. So if let me see here real quick. I think I still have it in my downloads folder. Guys, give me a sec here to check. What was it called? Bracket scan. And these are all Fusion files. Now, I don't think you sent me the original step file, if that was the case. You sent me the Fusion link, which keeps it as a Fusion file. You guys are going off in chat today. I love to see it. So the issue is, though, EJ, I need you. So this right here, although it is a step file, it did come in as a mesh. We need to do the insert mesh trick, which we might be able to do it. So let's try it. Insert mesh. I don't know if it's going to accept that actual bracket from yesterday, or last week, I should say. Here we go. Shouldn't be a new folder. Yep. See, so what I am going to have to do is completely fix everything here. So we're going to actually have to export this mesh. Let's see if we can. Might be able to direct edit it too. Let's see. Yep. So direct model edit, faces. Give her a second here. EJ, what is this part 2? Can you tell us? Now, this is probably going to be one of those times where it's not going to be very happy. Go 5" and see what we get. Guess we can't go inch. What's the, what is it, like 20 millimeters is about the same? Give me a few seconds here. It is now going to calculate, which leads me to a great time to 1. We've been going now for 1 hour and 10 minutes. So we're just past the 1 hour mark. And today we do plan to stay live all day until you guys stop asking questions. But what I'm going to do is I'm going to go ahead and switch over and get you guys with the good old fashioned how to support our channel, how to support us at jitcadcam. Now, as you guys have saw, Stuart has already bought us a beer out there, which is always a good way to support. It's a cheap, easy way. Come in here, ask some questions, get some answers, give a little bit back to the channel outside of our good old fashioned likes, subscribes, and of course, sharing our content to other people. But if you want to up the ante, nothing goes good with a beer like a steak, or you can actually purchase your Autodesk Fusion subscriptions through us. We offer support packages, custom one-on-one training, and even in-person training. Of course, anybody out there that lives somewhere that is a very nice tropical climate would be more than happy to do some custom on-site training with you guys. So let me get back here. As you guys are seeing, my computer fans are kicking on. They are starting to sweat. But with that, does anybody else have any other questions in the meantime while this is running? Anything they want to see in particular? Let me go ahead and jump back over. Again, EJ, I know you keep sending me this file, but the problem with that file is I need the original file, not the one that you uploaded to your Fusion team. So let me go ahead and jump back down here. So you need to send me the STL file, not the link to the Fusion Cloud to download that file. In 1 sec here, guys, just double checking all of our bases, make sure everything and anything's been good. This thing is not happy, but we're going to let it do. We're going to let it see. I mean, at this point in my life, I don't need diapers, Stella. It's all good, man. Don't worry about it. You don't have to spend $1. I think the beers on the website are what, $3? Do you guys know what the beers are on the website? Are they still $3? They're not Minneapolis Airport. I can tell you that much. My computer is not happy. A taper sprue on a mold. Ash, do you got a model I could take a look at? Give you a few seconds there. Again, we may have to change some settings here. Nothing like crashing Fusion in real time. As you guys are seeing, though, she's calculating. We pull up the old task manager to see what's going on. Oh, she is slammed right now. We are using all the CPUs as we can, at least as many as we can. As you guys can see, we are cranking. It's still calculating. We're going to let it sit here a little bit longer. Sure, sounds good. Go ahead and cut up a part of that model and send it over, and we'll take a look. Guys, I might just have to shut this down and go back. The good old-fashioned Fusion trick, which is zero patience on my end, means we're going to go back and change our settings and do it again. Well, give me a sec here, guys. I'm going to pop Fusion back open. It did not crash this time, for the record. And it did not crash because of me, as in the first time round. I'm forcing it to shut down. So give me a sec here, guys. We're going to go ahead and pop open that file one more time. Maybe. Let me get back into my Fusion Friday. Back to that part that EJ submitted. And we can go back to sharing my screen. So we're going to do this one more time. Let's take a look at this. Back into our mesh. Again, a lot of stuff is going on. And if you guys are wondering, if I zoom way in here, for example, this hole is probably about the size of a quarter. Each one of these little triangles is the problem when it comes to grouping these things together. So let's go ahead and try this one more time. Let's switch to the good old-fashioned bald eagle units so that I know my scale. And again, we're going to go in and we're going to generate face groups. We are going to, let's go, yeah, minimum group size 20. Well, that's the fast. If we go accurate, let's bump this up to go 10,000 to start. See what happens. Doesn't like 10,000. Do we got to go smaller than 10? Oh, we just backed out. Try this one more time. You know what? We're going to go ahead and do the fast version and see what we get. How's everybody's Friday going otherwise? As you guys can see, we're having nothing but a good time with meshes this week. You guys are going to make me go learn meshes over the weekend so that we could do this much better. Now, those settings partially did work. We obviously have to refine this some more, but we are getting some face groups. Now, again, the real problem with these face groups is if you notice on this hole here, is it's not really as clear and clean as that ashtray was, where it's a cylinder into a fillet, right? So this is where you get into those very interesting times of having to like reverse engineer a mesh. We're going to go back to 25 down to 2 and see if we can't get some more groups set up. Apologize there, guys. I do see the questions slowing down, so I'm curious. Is there just no questions to be asked? Anything in particular you guys want to see? I know a couple of my Facebook posts just went live. We should be seeing a little bit more of an inflow of people. Anybody looking forward to the weekend? Anybody working Saturday? That's always a good question. How many of you guys out there are working Saturday this week? EJ, what is it that you're machining on this part, if you don't mind me asking? Again, we'll give this a few more minutes. I might have to shut it down once again to take a look. Scroll back up. Make sure we didn't miss any questions along the way. Did anybody have any questions that got missed? Are we back? She's waiting. Something's going on. Maybe my other system's crashed. Oh, she's still calculating. Hey, that's a little better. We can start to work with that. EJ, as you're seeing here, a big part of this is going to be the fact that we need to get the face groups working right, but you're going to have a lot of time in trying to actually generate the face groups properly. Because right here is, if you guys didn't see this here, that actually looks like a threaded hole. So when they scan that, that's going to be the real pain in reverse engineering something like this, is the fact that you have things like threaded holes that were scanned. Again, this is what I assume is a casted part to start with. Am I correct? I'm going to go ahead and grab Ash's part. Ash, give me a second here. I'm going to jump over to the other side of things. Get this file downloaded and uploaded. Give me a few more minutes here. But yeah, it looks like there is a lot of possibility here for EJ's part. We just have to spend a little bit more time, a little bit more refinement, and a lot more calculating from a computer to get that information put in here. So again, give this a few minutes. We're going to go ahead and jump over to Ash's design part. I'm seeing more people come and go inside of here. So if you guys do have questions, anything you want to see, any particular problems you're having inside of Fusion, feel free to send it over our way. We'd be happy to show it in real time and see what we can come up with. So what exactly is it that you're looking to do? You said something about a taper. I'm assuming that's the taper you're referring to. And is that a straight on taper? Yep. Do you know what angle that taper is? I guess would be my question at the end of the day. Because to me, something I might actually do on a part like this is I would probably go in, Ash, if I was you, is if you had a tapered reamer, that would probably be your best bet to be able to go in and create that feature. Now, if you're trying to end mill something like that, it's going to be, yeah, it's a number 4 pin taper. Okay, so that would be, I don't know what the specs are off the top of my head, guys, but you would need to go in and basically pre-drill something like that. So let's go ahead and jump over to manufacturer. So again, we'll do our setup real simple here. Z-axis up. And then if we pre-drill that, I am going to need a size for my drill. So again, we have a minimum size here. Diameter 150. Drill, select. 150 drill. I think I saw a 147. Go undersize a little bit just to be safe. Now, one thing we may or may not be able to do is pick our hole faces. Now, given that is a tapered hole, it's not the biggest deal. A few other things that I would do is I would always auto merge hole segment if I can to bring up the top of the drill. Now, I may need to manually do things from a selection. As you guys are seeing, is I could select my model top. I could also, you know, go past the bottom, drill tip through. Pretty standard stuff here. And as you're seeing, we've now pre-drilled for that reamer. Now, again, it's going to be based off your guys' settings at the end of the day. But if I go in, again, a drill, this time we're going to create, and we have a reamer. Now, the problem is you can't actually give a reamer an angle. So there's no settings for a reamer angle. But what you could do instead of that is if you create a end mill, if I remember correctly, I believe you can do a tapered end mill. Now, it's been a minute since I've done this, but that would be a way around what you're trying to do. Let me go back here, cancel one more time. Tapered mill. See, yours truly making mistakes, but I would need to know the information based on that, if that makes sense. So one, you probably don't have a corner radius on this. I'm going to need to know the actual angle. I'm not going to look it up, guys. If you guys want to look up a number 4 taper, please do. We do now have our flute length, probably closer to 4 inches. 4 inches. Keep going here. And then we are going to need what I would assume is a diameter, which we know that's 150 at the bottom. Now, I would need to be a little bit smaller than that as well. But now that I have my tapered kind of tool, again, I do my drilling based on that feature. Just like that, I've created my drilling cycle. I think I'm off. I think it's actually less than 2 degrees, judging by what I have. But this is the way I would go about something like that. Again, is there's reamers set up for this. As I always tell people, Pops back in the day used to do this on a Bridgeport, right? So that being said, this is just one way of many that you could go about setting up and creating that feature. I think it is less than that. Isn't if we do a section analysis real quick. Did you give me an origin anywhere near? Oh, you did. Thank goodness. Also, there we go. And get our stock out of the way. Let's simulate it real quick and take a look. Get our stock out. Yeah, I think it's 2 degrees inclusive, 1 degree on both sides, and that's what we're seeing there. So, calculate speeds and feeds for a tapered tool like that. Ash, what I always point people to is, one, depending on who you buy the reamer from, they can provide you speed and feed information, and obviously, the good old-fashioned Google is always a way to go. So again, we're going to go to 1 degree. And let's go ahead and regenerate and then simulate that one more time. Yep, it looks like it was 1 degree versus 2 degrees overall. Now, again, there might be a little bit more to that, but as you're seeing, that would be one way you could go about it with a tapered end mill as a reamer so that you could ream a tapered hole. Questions, guys? Any more questions out there? Anybody? I see quite a few of you guys hanging out in here. If you guys have any questions, feel free to throw them in chat at any time. To go ahead and jump back our tickets. Nothing. I see that there's not a lot of questions coming in. I see quite a few of you guys in here, but no questions. So is it time to call it? Is this it? Going once, going twice? Is it time for Fusion Phil to kick off his weekend? I think that's it, guys. I think that's it. I'm going to go back to my beautiful face as always and tell you guys it's not what you know, it's who you know. And you guys know Fusion Phil over here at jitcadcam. We are an Autodesk reseller. We are here to help you guys in any way, shape, or form as much as we can. And we appreciate anything and everything. And as Stuart has done for us oh so kindly, he has bought us a small pack of diapers for my brand new baby daughter. So we appreciate that. We appreciate you guys. And we always look forward to these Friday situations, even when we get tangled up in mesh stuff like you guys have seen. But with that, yeah, I mean, it is always extremely slow. But thanks, Dylan, for the congratulations. Also, I hope you guys have an outstanding weekend. And if you are working Saturday, I hope you are getting an absolute killing in overtime pay. But with that, we will see you guys. Should we do Stump the Chump on Monday? Let us know in the comments section down below. Feel free to message us in with a part if you guys want to see Stump the Chump on Monday. And we will be here to help in any way we can. Thanks, guys.